In this video, we're going to discuss more about what is a vector. Well, a vector quantity is one that has both magnitude and direction. So for example, if you had a car moving to the right at a speed of 10 meters per second, then we would say the velocity vector had a magnitude of 10 meters per second and its direction is to the right. Together they make up a vector quantity. Keep velocity and scalar quantities separate, we use a notation. So the notation is, for a vector quantity, we take the symbol and we put an arrow on top of it. So for two examples here, if you have a force vector and a velocity vector, notice I use F and V and I put arrows on top of them. Those symbols mean we have vector quantities. For scalar quantities, we don't use an arrow. So notice here for mass and temperature, which are scalar quantities, I don't put an arrow on top. That indicates that these quantities are magnitude only. So for any general vector quantity, we use its symbol, in this case a capital A, and we put an arrow on top. That indicates it's a vector with magnitude and direction. If we're only interested in the magnitude portion of a vector, we use that symbol with the arrow on top, but we put absolute value signs around it. Alternatively, you could just use the symbol by itself with no arrow, no absolute value signs. That also indicates magnitude. However, I would recommend using the first one because I think the absolute value signs explicitly say we're looking at the magnitude. Put it all together with an example. Say I have a force that is 20 newtons directed to the right. I can write the magnitude using the absolute value signs as 20 newtons, and I can set the direction as to the right. We will see coming up a more mathematical way of defining things like to the right. Also show this vector graphically or by drawing. Now notice here, I have an arrow pointing to the right. Now the arrowhead indicates the direction of the quantity, in this case the direction of the force, and the length of the vector arrow itself is proportional to magnitude. So you usually use some sort of scale when drawing these to make them proportional to the magnitude. Later on we'll see sometimes you can just sketch them and it works out just fine, but mathematically we can use these drawings to actually solve problems. Another example, I'm going to put two velocity vectors here. V1 is 5 meters per second directed to the right, and V2 is also 5 meters per second, but it's directed upwards. Now, notice I've drawn these with a scale to indicate that 5 squares on the graph paper is equal to 5 meters per second. And you'll notice if I measure the length of those arrows, they're the same. That would tell me graphically that the magnitudes are the same. In symbols, we would write these two vectors. You could write their magnitudes being equal as V1 with absolute value signs and an arrow equals V2 with absolute value signs and an arrows. Their magnitudes are the same at 5 meters per second. Also notice their directions are different because the arrows point in different directions. Let's alter the example a little bit. Let me change V2 to be 10 meters per second, but to the left. So now I'm going to draw these two vectors so you can see them. And you can see that the arrows point in completely opposite directions, indicating, of course, that one is to the right, one is to the left. You'll also notice that V2 is drawn at twice the length as V1. That indicates it's twice the magnitude as V1. So 10 meters per second versus 5 meters per second. Vectors can point in all sorts of directions. In 2 dimensions, we generally use an angle to help us define direction. However, 3D vectors can get even more complicated. What we will do in the next video is start to put vectors on a mathematical foundation to show how we can easily solve problems with them. Now I'd like to thank you for watching the video. Feel free to subscribe to the channel. Please go on to the rest of the series on vectors and have a great rest of the day.